Now, what we're looking at today are transformations, applying transformations to functions, and we've done this before. And the lowest or highest point on a parabola, so our U-shaped graph, this lowest point is called the vertex. If it opens up, the lowest point's the vertex. If it opens down, the highest point's the vertex. And we call this the vertex form because the HK value is the vertex. We'll get more into this into 2 and the rest of this chapter. So it's not as crucial here, but it is one part of it. Now you don't have to write all of this down because I'm more referencing at this point. We won't use it too much in this here. Take 3. There we go. Circle. There we go. So A indicates a reflection in the x-axis and our vertical structure shrink. We've gone over this. H indicates a translation left-right, our horizontal translation. And K indicates a vertical translation, it moving it up or down. Again, we've covered all of these different parts. So when we look at this first set of transformations here, let the graph G be a vertical stretch by a factor of 2. Reflection in the x-axis, followed by translation at 3 units down of the graph f of x equals x squared. Right of rule and identify the vertex. On the homework, I'm not going to make you identify the vertex for these here. We're mainly just focused on the transformations at this point. So we have 3 different transformations. I'm just going to name the first one m of x for our vertical translation or vertical stretch of 2. As we denoted vertical stretch or shrink, especially applying it as our a times f of x. And here, the amount that we're stretching or shrinking the function by the a value is 2. So we're stretching this function by a factor of 2. Our value of a is 2. So we have 2 times f of x. Well, f of x in our case is x squared. So we have 2 times x squared, or we can just say m of x is 2x squared. Questions about this so far? Because we've done this before, we're just looking at it again. Our next transformation was a reflection in the x-axis. This would be our negative f of x. Or in our case, it would be negative m of x. We're applying it to that function that we just had our transformation. Well, m of x in our case is what? 2x squared. So we'd have negative 2x squared, which is, well, just negative 2x squared. And our last transformation is translation 3 units up. So we'll call it h of x is our function. We're applying it to g of x plus k, where k is the amount we're moving the function up or down. And since we're moving it down 3, we would have minus 3. That's it there. Questions on this here? I think now that we've seen it a few times, it's making a little more sense, yeah? Questions on this here? Okay. Textbook does it a little different than this, and I'm going to actually show you the way the textbook did this. Were you all still copying? Okay. You're welcome. At any point, if I do go ahead or you need something, tell me. We good with this here? Okay. Now here, as they gave us a minute ago, this was the formula they gave us. And A was our, if there's a reflection across the x-axis, we have the negative, and the vertical stretch or shrink. We do have a reflection across the x-axis. So the value of A will be negative, and it would be negative 2. H, there is no movement left or right, so H is technically 0. And K is our movement up or down, so negative 3. So the book would say that, well, A we can replace with negative 2, H with 0, and K with negative 3. So the negative 2. Our x minus 0 squared is just going to become x squared. Then we have and we get this here. Now, it works just fine, but the only thing I have issue with this is this way works if we talk about the vertical stretch or shrink before, we apply it before our vertical translation up or down. We apply the reflections before the translation up and down. So both vertical stretch and shrink and reflections in the x have to go first before up, down. Same with horizontal. If we have a horizontal stretch or shrink, it has to be applied really after the movement left or right, and the reflection across the x-axis has to be applied after. They have to be applied in a specific order for this to work, where we can just plug those values in. Because if it did it in a different order, we would get a different equation. Because when we did the reflection across the x-axis, we had to apply it to every term. So if we did the up-down, well, it's not just, let's go back. Because here, when we applied that negative all the way through, there was just 2x. If we'd have moved it up, down, that minus 3 was here. That negative does not only go to the 2x squared, it also goes to the negative 3, turning it from negative 3 to positive 3. Because they did it in this order, yes, we can plug those values in, it works. But if the order's changed, it changes the equation. Does that make sense? So plugging in, it works if vertical stretch or shrink went first, then the reflection, then the up-down. If it's not that order, that method doesn't work. But the way we did it here works no matter the order. That's why I show you this way here and not that way. I'd rather give you all a method for doing this or having a way to do it that works every time, not just in these certain cases. Does that make sense? I'd rather teach you one way, not several ways. Especially if there's a one way that works. Now, because again, the way we did the last one would still work here. A is 1/2, K is 2, we plug them in. If we do it the way we've been doing it, because there's 2, we can start off with our vertical shrink by a factor of 1/2. H of x equals A times f of x. Well, our A in this case is 1/2. F of x in our case is x squared. So we'd have 1/2 times x squared, which is telling us h of x is, well, 1/2 x squared. Questions on this here? The only other translation we have for this is 2 units up. So it's our h of x plus k. Bless you. Since we're going up 2, it's going to be plus 2. H of x for us is 1/2 x squared. Questions on this here? We're going to do one more before we wrap it up today. Are you ready for the last one? Let G be a horizontal shrink by a factor of 1/3 and a reflection in the y-axis, followed by a translation 2 units up of the graph x squared. Now our first one is this horizontal stretch or shrink by a factor of 1/3. Horizontal stretch or shrink is our f of a times x, so that's whatever we name the function, ax, where a is our factor that we're stretching or shrinking the function by. Now it'd be very tempting to want to put 1/3 in for a. We have to flip it so it's 3/1 or just 3. Because our horizontal stretch and shrink does give us that little bit of a hitch that we do have to take care of. So 3x. So what that means for us in finding this function is that every x in f of x has to be replaced with 3x. So our x squared is now 3x squared. We're squaring both of those terms. So 3x squared, 3x times 3x is what? So 3 times 3 would be 9. X times x would be x squared. So we can say m of x is 9x squared. Now, if it had had x plus 1 or 3x plus 1 in there, we'd have left it. It's 3x plus 1 squared. Mainly because if we had this, I wouldn't write this out. I'm just putting this as a side note. 3x plus 1 squared is 3x plus 1 times 3x plus 1. We have to distribute through, or FOIL. We have to multiply it all the way out. We get more than just the one term. So we'll leave it alone, especially in vertex form. Our second one was the reflection across the y-axis. And our reflection across the y-axis is our negative x. Normally, as we wrote it the first time, was f of negative x. We're not applying it to f of x, we're applying it to m of x. So it's m of negative x. Now we're going to place every x in f of x with negative x. So that means we'll still have the 9, but now we'll have negative x squared. Now, if we wanted to, we could leave it as 9 times negative x squared. Negative x squared, just like 3x, it'd be negative x times negative x. What's negative x times negative x? Positive x, so it tells us it's 9x. It really doesn't do a whole lot, especially when the vertex for this is on the origin. So all the points to the left of the y-axis got flipped to the positive side. Well, they landed on every point that already existed on that side, and all the ones on the right went to the left. So it literally flipped it onto itself. That's why we came back with the same function. There's one of the points, so 9x squared. I'll give you t-table just so we can kind of see this. For our 9x squared, let's go x, y. So negative 2, negative 1, 0, 1, 2. Well, 0 is still going to be 0. This is going to be 9, and then 2, 4, 36. Okay. So 9x squared, we would get this table. I'm just, again, you don't have to write this down. I'm just showing you this here. When we reflect it across the y-axis, what it's saying is at this point here, this y value is now going to correspond with positive 1. This positive 1's value is going to correspond with negative 1. Those flipped. But that still gives us the same point, yes? That's why when it's on that y-axis, nothing changed because the left went to the right went to the left. It mirrored itself. Does that make sense? When these values are something different, we do get a change because it's a different value switching there. And this is just a general kind of brief overview. Anyway, so reflected across the y-axis, we just get 9x squared. And last one is 2 up. G of x, h of x plus k. Well, our k value would be plus 2. H of x is 9x squared. And your homework assignment. It should seem familiar. Still the same.